So we can start.
We can now?
Yeah, now.
Okay. Good morning, friends. Welcome to the online program being organized by Nehru Science Center in collaboration with the Nuclear Power Corporation of India Limited. In fact, this program was planned as a part of 75 years of India's independence, Azadi Ka Amrit Mahotsav. And we have organized many, in fact, lectures as well as competitions in collaboration with NPCIL. And the basic tagline was that nuclear energy, green energy, clean energy. With that theme, centering around that theme, we have organized many programs, competitions, online quiz, painting contest, and lectures. I think today is the fourth interaction in that series. The first one was by Dr. C.M. Notial from Lucknow, and now with INSA. Then Dr. Shri A.K. Jain, who himself was from NPCIL, now retired from there. And then Mr. S.K. Malhotra, who was with DAE and a public outreach head also. And now we have with us today Dr. A P Jayarman, who is the president of National Center for Science Communicators. Along with that, there are many other things. In fact, whatever will be said, that will be less so far as Dr. A P Jayarman introduction is concerned. What we have, in fact, I personally feel that he is a mentor for us also. He guides, he's very passionate science communicator. He is the member of scientific committee for PSTC. Then he is principal scientific advisor also for this HNSC University, Hyderabad Sindh National University. In fact, he has been instrumental in starting one science course, means this communication diploma also. And already I think 1 or 2 batch they have completed in that. In fact, he himself is a nuclear scientist. And just briefly, I will introduce a few things about him, and then we'll go for interaction. He holds a PhD degree in science and also postgraduate diploma in material management, also in management, and then a diploma in engineering. He started his professional career at the age of 22 after graduating from the Elite Scientific Officers Training School of Atomic Energy Establishment. He had a distinguished and diverse career in several disciplines and divisions of Department of Atomic Energy, which shortly we call as DAE. And this span is of almost for 40 years. After retirement, he relocated to Singapore and then worked there as a professor of environmental engineering for Griffith University. He served as Dean Academic, Sadanam Institute of Management Studies, Palakkad, which is in Kerala. He is the chairman of National Center of Science Communicators, which I have already shared with you. And he is also the president of the Academy for STEAM. STEAM, I think all of you are aware, it is science, technology, engineering, art, and mathematics, which is a buzzword now in scientific fraternity and communication particularly. He is the trustee of Indian Development Foundation, IDF, and is engaged in interacting with teachers and students across India. In fact, on several programs, he has interacted with, I should say, more than 50,000 students and 7,000 teachers and over 100 schools. In fact, still he is continuing as a passionate learner also, as well as communicator. I remember during the entire period of Corona, on several occasions we have interacted. He is always online, attending, and almost, I can see, almost more than 35,000 hours, sir. Yeah. Doctor for the science communication and yeah. So wide experience, traveled extensively to different countries. Today we have requested him that nuclear science or nuclear physics, nuclear power, there are many aspects of that, but very few people know about that. When we have in our country nuclear power, nuclear energy, and a lot of crisis also in some of it. Now I think it is being resolved. But as we told, And recently, there are a lot of developments. We are discussing about climate change. We are discussing about global warming, fossil fuels, and there are many other burning questions, climate, environment. So as we were discussing just a few minutes back, that nuclear energy, nuclear power, they are all connected. In fact, it is the base of what you call the uh, every science, you can say somewhere it is connected with that. Sir, I will just have some interaction and regarding this to start with, since you have spent almost 40 years in this field, communicating, learning, as well as in the nuclear power plant, I think on many aspects, you have been also communicating through DAE media channels, and later on writing the books also. 100 means several books. The latest one, I think it is you shared it with us. 100, we are 118. It was International Year of Periodic Table. Uh, so so far as nuclear is concerned, considering your vast experience, you started this advocacy also when you were maybe communicating from DRC or DAE rather, I should say, on a larger front. What do you think? Where do we stand today? Means, what is your opinion? You have been advocating for this. We are also doing that. But as a science communicator to the public, because they have many perception, maybe different perception coming through media channel, through social media, or through other channels, print media. What do you think? What you would like to say about your stand today, so far as nuclear power is concerned?
Thank you, Director Umesh ji, for this lovely introduction. It is pleasant to hear compliments pleasanter still from a director who is daily engaging in science communication. So I'm grateful to you. I'm also equally grateful to Nuclear Power Corporation of India for their very responsible and responsive reaction to the nuclear renaissance age which is happening right now. So we have the right combination. I personally feel that you are asking this question whether green and clean energy. Look at the words GREEN, green, CLEAN. These 5-letter 2 words is the real thing of modern life. Shakespeare once said, green indeed is the color of lovers. Today, green is the loud color of all energy lovers. Everything we want green. And when we look around, we find many things green. Some are deep green, some are dark green, some are light green. So green, we don't have a green meter. Greenness or greenishness is calculated, assessed. And if we have a greenometer, which I think scientists should be able to find out, nuclear energy will stand first and foremost in that scale. That is the beauty of it. Many people have painted it red, dark red, crimson red. And there were many green organizations painting nuclear power red, which is a travesty of truth. The fact is, if you ask me the question, is nuclear power green? My black and white answer is, it is green. It is pure green. Of course, it can be greener and it can be made a little more green. That is where technology comes in. So if you ask my perspective, I have gone through this. In fact, I started my nuclear science communication career in the most radiophobic country in the world, Japan. On the 25th year of Hiroshima, we had the exposition, Expo 70, Osaka, Japan. I spent a year there explaining atomic energy to the Japanese people. And they looked at me in wonder and also with disbelief. Why this Indian is coming over here and explaining the virtues of nuclear power? That was a romantic phase of nuclear science communication. And we had a wonderful conceptual artist, Alik Padamsi, whom Sarabhai had engaged to design our pavilion. And the pavilion was all mushrooms. Mushrooms from the floor coming and spreading its hood, giving out one application of atomic energy. So we gave a new metaphor to nuclear power. We gave a new interpretation and a new meaning and a new impetus to nuclear science communication. That is how we started. Now, if you ask this question, to see things, everything in green and red, that is a bipolar disorder for most of the media. I would say severe bipolar desire. Now, greenness is calculated, assessed, judged. by technical experts. If you draw a graph, on the y-axis, you put the amount grams of carbon dioxide per, let us say, a unit of electricity, per kilowatt hour, the unit of electricity. Then we will find that it is the nuclear which has the least amount of carbon dioxide being released for every unit of electricity produced. And almost about, I would say, 820 times of that is being consumed by our coal stations, the fossil fuels. Of course, I am also a fossilized scientist, having spent a lot of time, but I am dead against fossil fuels. You must also remember one more thing. There was a limits to growth concept in the 1970s by Meadows and the Club of Rome. They said that coal will last only 100 years. You can't run business as usual with this. So we should look for a new source of clean and green power. That is the inevitable option. Nuclear energy is the inevitable option. We must also remember that there is no free lunch. Any work you do, it will produce some waste. There will be some impact. But the minimal harm which is done to the environment is by the nuclear power. That's my... So I find an emergent nuclear renaissance today. And I'm very happy that you have organized this meeting where I could just mention the word nuclear renaissance because it is a renaissance.
Yeah, that's true. In fact, just taking it further, well, your use, I think that is the necessity right now, because people, it is something wonderful. Means you started in Japan, because those who have suffered because of this power, means when this nuclear bomb blast, and then they have come across through that, and you have gone there, explained it to them. Perhaps they might have asked you also, means since you have not faced it, how you can understand what kind of problem they have faced out of it. But yes, that is the truth, that we need to create a different metaphor, what you have, which you have done in Japan, and you have used this word bipolar also. Means, in fact, in one of the lecture, it was said that now I think it is not only one or two. I think we need to go through whatever, except say fossil fuel use, whatever is possible. Perhaps we need to explore all the possibilities to find out. So now you have already told that since it is a green energy. So when we talk about green energy, nuclear power and climate, because now we are talking about agenda 2030, 2050, 2017, we have to control the carbon emissions, and we have to reduce it to, we have to take an approach so that we can go for zero emission sometime. And we have to reduce almost say by 55% fossil fuels use by 2030 or so. In this scenario, means how do you think that nuclear power can help and will be really beneficial for climate change which is happening, to control that or to mitigate the effects of this? To what extent it can be useful if we go for nuclear power?
See, that is a very hot and spicy question you asked. Climate, weather, these are the two words lingering in everybody's mind today. When you look out, we find a weather, either hostile or favorable. And we sometimes used to say the weather is bad, but climate is good. But if climate is bad, weather can never be good. So that is the main philosophical nexus between this. When you speak about the climate, the most important thing we should bear in mind is global warming. We cannot give a warm welcome to any change in the climate. So to help the climate, we must put a stop. We must decelerate the global warming process. Of course, we have a magic figure, 1.5 degrees Celsius.
Yes.
We should not exceed that. But have a close look, my school friends, teachers and students, at 1.5 degrees Celsius. If you convert it into Fahrenheit, it will be 2.7 degree Fahrenheit. Now, our body temperature, you add 2.7 degree Fahrenheit, it will become 101.1 degree Fahrenheit, the right time to run to a doctor. And you want the planet to shiver. And there are no doctors who can treat our planet. So the only way we can do is to stop global warming. The best thing most students do today is to look at the carbon dioxide level this morning. There is a data available every morning, and this morning I looked up, it was 419 ppm. This is published by the daily carbon dioxide reading comes from Mauna Loa Observatory of the National Oceanic Atmospheric Administration. And in June, it crossed to 421 ppm. Today, it is 419. So we should be able to reduce this. And nuclear power has the capacity, has the sure capacity to do it. For those of us who are interested in dealing with the back of envelope calculations, we can find that over the past 50 years of the existence of the nuclear power operation, we have been able to remove so much, that is 60 gigatons of carbon dioxide would not have been released to the atmosphere but for the operation of the nuclear reactors. And 60 gigatons per head will come to 1 ton per head. I'm sorry, 10 tons per head. Can we carry an overburden of 10 tons of carbon dioxide? And this is what happens if we do business as usual. So all climatologists give a green signal. The COP26, they have also said in the new taxonomy of energy, that is on 2nd February 2022, the European Union confirmed the green label to nuclear power. So we are officially green, apart from scientifically being green. So I'm sure, absolutely sure, that nuclear power can turn the tables of this climate change if it is meaningfully and successfully applied.
So, sir, yes, recently European Commission, they have given, I think a few people were opposing also because there are some other aspects they say, but there are some parameters perhaps based on which they must have accepted that nuclear power. And I think gas power also, along with that, they have given the green one. Though nothing can be 100%, you can say, but they say it is rated, I think, at the second level, other than hydro. So even we also have carbon footprint. We also emitting CO2. But if you consider on the industrial scale, I think nuclear power is far better. In fact, when we went yesterday to the DAE exhibition, so there they have shown the kind of radiation means which is coming out of it, and they have compared it with people, because some time back I remember I gave this example when people are not understanding that, when they are going inside for X-ray or for, so sometimes they accompany with them, they don't understand that they are all cumulative effect, and once you are exposed to that, it remains with you. So there is no need to go. In fact, I went to this one of the hospital and they said, why you're allowing people? We tell them, but they don't understand. They want to come with that. So I think that is the kind of awareness for us. People need to understand that if something is not required, they should stop. Sir, you said about this 490, I think ppm, that CO2 data which you have shared. Up to what extent means? Sometime I read that they say it is reversible, but up to what extent? Because there cannot be reversal. Like if you stretch a rubber and take it to certain extent, after that it will break. Or before that, if it is elastic, elasticity is not gone, perhaps it can stretch back. So up to what level of this ppm of carbon dioxide, like 490, is there any limit set that up to this point we can go? If once it goes beyond that, perhaps it will be irreversible or we cannot come back?
There will always be an irreducible minimum of carbon dioxide in the air. Look at ourselves. We are all heat engines. I am a 100-watt thermal machine. I eat food. I exhale carbon dioxide. And there are 8 billion people doing this. So there is a human element of carbon dioxide constant creation that is always happening. And other living organisms also do this. The metabolic process is constant. But industrial development has put in a new dimension to it, the burning of coal. And the burning of coal is the single critical variable for the elevation of carbon dioxide right now. And to project the figure at which the saturation value, it will be very hazardous because we can't do experiments on that. All that we do is the lesser the value, the better for us. So reduction of that is a decarbonized economy is how much you can do. 1.5 degrees Celsius we should not cross. That is the rule of thumb given to us. So we have some parameters available, but better parameters at operational level, at tactical level, at strategic level will be available to us for more and more climatologists, and transdisciplinary work is done in the field. For the time being, let us look at what is today's value. Is it worse than yesterday? So that should be the pragmatic approach which we can follow today.
Oh, yeah. Actually, you told about the air quality also. And in fact, you very nicely explained that 1.5 degree concept, converting it to Fahrenheit, that if happens it to us, then you are, it means you assume that you are on fever side. And nowadays, particularly after post-pandemic, so if you have that kind of fever, if you don't say if it is not subsidizing, immediately you have to run to the doctor. But when it comes to air quality, because we all the industries now AQI every day people are monitoring, even TV channels, many of them they are streaming it, also taking, and in fact some of the science centers or at some major crossing they keep on telling about what is the AQI today through traffic police, you can say. So what how it is related? Can we relate this nuclear power? Because the percentage of nuclear power being generated as compared to the coal or maybe other fossil fuels, it perhaps is very less. Maybe the entire world, if you go, I think it is some 10%, or maybe in India somewhere it is 5%, or maybe even less. So how we can relate, as you said, to the air quality with nuclear power, means how we can correlate both of them?
Oh yeah, that's a little complex question, but a very relevant, significant, piercing question. Yes, first and foremost, let us accept this axiomatic fact that nuclear power is clean energy, which we have argued. We are not burning fossil fuels. We are not letting anything into the air. That is one very important. Now, the most powerful factor is this. We take about 1 kilogram of food, about 2 liters or 3 kilograms of water, but we need 5 kilograms of air per day. So the air quality is absolutely important for our existence. And there is no air pollution from the nuclear establishment. Now, you look at there is what is known as TLVs, threshold limit values for different chemicals, for different air pollutants and indoor pollutants, given by the American Council of Governmental Industrial Hygienists. Now, when a fossil fuel plant burns carbon and produces carbon dioxide is coming out. The threshold limit value for carbon dioxide is pretty high, 5,000 ppm. That's a pretty large figure. Good, but we can't do that for a long time. And if you look at carbon monoxide, one of the most toxic substances, it is just 25 ppm is in the air, you are in bad shape. But a fossil plant also gives sulfur dioxide, nitrogen dioxide, phosphates, and particulates. So the air pollution quality or the air quality due to pollutants is very bad around a fossil fuel. If you monitor around this, you will get, I'm not referring to carbon dioxide and carbon monoxide, but particulates, nitrogen dioxide, sulfur dioxide, arsenic oxides, phosphates, all the impurities which are in coal, which is a mineral, is brought into the air into respirable form. So we have different criteria for respirable dust. For example, respirable particulates, we can have 3 milligram per cubic meter. That is the current value for the American Council of Governmental Industrial Hygienists. A huge amount of scientific technology community was involved in calculating how much air pollutant can be tolerated for an 8-hour exposure. That was necessary because pollutants were coming to the air. Now, as far as the nuclear power is concerned, we produce the finest high-efficiency particulate filters, HEPA filters, because we wanted to filter the air. Any air which goes from a nuclear power plant goes through a stack, which follows certain laws of formulas. There are detailed investigations. In fact, I remember in the 1960s when I joined the atomic establishment, there was an air monitoring section under a very renowned scientist who was calculating this 1960s. So we have very strong, long foundation, a legacy of air pollution control, and nuclear power stands first with respect to its basic understanding and application of technology for air cleaning purposes. So that's one aspect. In fact, air pollution is absolutely no pollutant coming from to the air from the operation of a properly managed nuclear power.
Yeah, yes, correct. It is, you said it, like SO2, nitric oxide, sulfur dioxide, and many other arsenic oxide. All these, I think some of them are leading to what you call fog, or maybe the dense, and then acid rain, all those things, which perhaps since nuclear power is free from all them. So and you have already mentioned about, like, in whatever they are producing, 60 means, which equivalent to 2 years of that, 65 gigaton of carbon dioxide. So air quality is definitely better with this. And in their surrounding also. In fact, I had opportunity to visit one power plant in Kota, because when we were developing this nuclear power gallery, and that environment stewards program which they are creating, because it's a highly protected area, so very less pollution. Even the water which was in their surrounding, that was also very good, and greenery, and what you call so many birds and all that. So I think they're all because of the good quality of air, and free from many other disturbances also. Okay, now coming back, I think somebody has asked in the audience also.
Yeah.
One question is about the cost of installation of a nuclear power plant, which seems to be high as compared to the world, which I don't know whether you can answer it better. But along with that, I have one more. I would like to club this with this question. When we are going for making power plant or nuclear power generation, so we have to take the land for any industry. But when we go for, because government is the only agency doing that, NPCL is doing that. So when we acquire land, so a lot of hue and cries, or sometimes how much land is required, or people have misconception, they need lot of land about that. But it is, nuclear power plant may not be that large, but in surrounding area, so a lot of area is covered under that. How do you think about we talk about carbon footprint, we talk about footprint, means water footprint, many other kind of footprints. What about the land footprint so far as nuclear power plant is concerned? Whether it's really required, means crores of acres of land, if you compare it with, say, solar power plant, or maybe a wind power farm or something like that. So how do you compare with that, and about the land footprint, if you can say something on that to our audience?
Oh, yes, Umesh, that's a very interesting question to look at the land from the point of view of energy. Land is very dear to Indians in particular. A piece of land. Yeah. I own a piece of land. It's a property. That's my value. That's my worth. And I am willing to pay any price and a cost for that. So land has price, cost, worth, and value. All the four economic parameters. And when some land is being acquired for a nuclear power plant, usually we will find a local hostility. Now, this local hostility is manufactured and engineered by interested parties. The lowest land footprint is that of the nuclear power. The reactor takes a very small area for its operation. In fact, the standard calculations released by the International Atomic Energy Agency for a 1,000 megawatt nuclear power plant is just 2.5 square kilometers. So that is the rule of thumb for the actual siting of the nuclear power reactor. 1,000 megawatt operational strength is 2.5 kilometers square. But as a measure of abundant safety, we also keep an exclusion zone around it. That's about 1.5 kilometers. But all the beautiful gardens and the residential buildings are inside this. This is more a statutory requirement. And also another statutory requirement demands that we should keep a 5 kilometer sterilized zone. So these are the technical requirements. So let's not go into that. But if you compare this with, let us say, hydropower, nobody bothers about it. Hydropower needs 33 times more land than this. And the land requirement for, let us say, solar plant or windmill. The windmill, you need a large area, very large area for its operation. Nobody thinks of those areas. Every moment, nuclear power, because you are trying to list out a number of your objections to this. How many objections can I raise to nuclear power? That seems to be the driving force. So they will look at land, they will look at water, they will look at air, they will look at the quality of life without understanding that the quality of standard of living is enhanced by this nuclear power. So there is a fundamental misunderstanding. And as far as land is concerned, let us very clearly understand that it is the least amount of area being occupied by a nuclear reactor plant operation. And its surroundings and environs will be beautiful sight, aesthetic, very pleasant to look at. And it is the safest place to stay and to walk.
In fact, we can request our young students that NPCIL sometime organize visit also. If you request through your schools to them, perhaps sometime you can get an opportunity to see yourself that how much land is required and what they are doing with that land. And perhaps your perception will change that as Sir has said, there is some fundamental issues with that, or it is created by some, you can say, some vested interest. So you just try to visit, maybe if you can get an opportunity. As I said, I had that opportunity, and I am quite convinced what Sir has said in this conversation. Okay, taking it further, what about the waste? Because mostly industrial waste. So since nuclear power, that's also a kind of industry. So what kind of waste it generates, and how much it will be, and how they, because sometimes people have a fear about from nuclear power plant, there will be radioactivity or radioactive water. So there may be many misconceptions with that. So that kind of waste, because radiations are coming, so you'll get exposed to that. So these things are created. What do you say about that?
Oh, yes. Umesh, that question of yours really reflects the mindset of the people. That is, radioactive waste is something hazardous and which is staring at us right in the face. Some 10 years or 20 years ago, this question was raised to such a high pitch and high frequency. Oh, waste management is a problem, an insoluble problem, a recalcitrant problem. Nothing can be done about it. So therefore, nuclear power should be abolished. But those who are in the business and those who are in waste management business know very well that this is absolutely manageable by current engineering standards. I will give you some example for this because I had the privilege of working with radioactive waste management for some time. And all the radioactive waste, it need not necessarily from the nuclear reactor. It can come from cancer research hospitals. Wherever radiation is used, radiation medicine, any material which is having radiation or a radioactivity, that way, a human body, when it is dead, is radioactive. It has carbon-14, it has potassium-14. So dead body is also radioactive waste in that sense of the term, in the absolute sense of the term. But when we have all the waste, we will divide into three categories. We have very low level waste, we have intermediate level waste, and then we have high level waste. Now, most of us are worried about this low level waste, but we should understand that 90% of the total waste is low level waste. And only 7% is intermediate level waste. And the so-called magnified, exaggerated high-level waste constitutes only 3% of the total waste from a nuclear reactor. Now, what do we do with waste treatment? We earlier used the term waste treatment. Then we converted into waste management because, we had to manage the waste. So all low-level waste, like used paper, filters from research laboratories, radiochemical laboratories, from hospitals, and so on, we burn them. Now you may wonder, you are burning it. So are you not polluting there? Our high efficiency absolute filter will take care of every particle and that could come out. So we do incinerate. We have excellent incineration technology developed in Bach. Then we have effluent treatment plants where the low level waste is being treated chemically and a sludge is produced. and we take out the sludge and condition it and put it properly. Normally, for this type of waste, we follow a method called ground disposal. We have a ground, huge ground, that's called a radioactive burial ground. In the radioactive burial ground, there are very special facilities prepared for this, engineering designs. We have the earth trenches, we have reinforced concrete trenches, we have tile holes. So appropriately, these are managed in this. I just want to mention to you, I have a number of student listeners here. Let us assume that one year, you are using nuclear electricity throughout for everything. You are only using nuclear electricity for 1 year. How much waste would it generate? That's a number which you should like to remember. The total waste that will be generated by your using nuclear electricity for 1 full year is the size of a brick. That is the total waste. But 0.3%, that is only 5 grams of that is going to be high-level waste. Now, this high-level waste has been drummed and sold to us as if it is some insoluble problem. It is not so. Engineers, chemical engineers, material scientists, and nuclear technologists have found solutions for this. Wherever there is a problem, there will be a solution. There will be a number of solutions. They will optimize the solution and accept the best one. The high-level waste is vitrified, solidified into a glass format, which is called borosilicate glass, because nothing comes out of glass. Glass is a very wonderful material. It has that remarkable property, the resilient capacity to retain all the radioactive materials within that. So we have found out borosilicate glass, in which this high-level radioactive waste is molten into that, is ingrained into that, is part and parcel of the glass matrix. What do we do with that? We resort to what is known as geological disposal. There are abandoned mines, deep mines, where we cannot do gold mining now or uranium mining now, but they have been structured and that is available, and they have been evaluated. They have been seismically, seismologically, and also geologically evaluated for their integrity, no cracks, faults, and all that. And these geological formations, it will be kept there for retention. They are called repositories. So engineered repositories will take care of radioactive waste. And that's not going to be very big, huge quantity either. It's not the fly ash from a fossil fuel reactor. So radioactive waste management, also it is appeared, we have magnified the problem. The problem has been reduced, and concentration and containment is the philosophy. And we have concentrated it, and we have concentrated it to the highest possible density. And now it is possible for us to contain this, isolating from the human environment. What more do you need as far as waste management is concerned?
And that also, perhaps they are within that land which has been allotted to them. They are burying in that.
Yes, Umesh, it will be under protective surveillance all the time. Vigilant eyes will always be there.
Yeah, in fact, yesterday in that exhibition I saw, I think now they have developed a technology where whatever waste they are creating, they have started with this tagline, wealth from waste. In fact, recently they have developed one for that. Some people have the cancer or maybe some sort of tumor in eyes, maybe in eyes. So they put something over there, and that is also out of this nuclear waste only they have created. And that earlier they were purchasing from a foreign country, which was costing to lakhs of rupees. They have brought it down to below, I think, 1 lakh or so. And like strontium I think strontium it was, where the lifetime half-life is much more. So now means what do you call, they say they can use at least 3 times that half-life, so that before it is unused, you can say. So I think lot many things are there. These children, those who are listening, if you are from Mumbai particularly and nearby, it is available up to 7 p.m. Tomorrow is the last day. I will request if you can make it with your parents or maybe your siblings or friends, just visit that. It is in DAE Convention Center. It's a wonderful exhibition. There will be many things which we are discussing here. You can see something live, some materials also, which you would love to see, and hands-on kind of thing you can say. Okay, I think there was somebody has written. You have already mentioned about that, I think, but uh, as we were discussing, other fossil fuels you mentioned they are for 100 years or so. So, but I think uranium, thorium, they are also not low that way. But since what you call more from less. So, do we have how long we can run? Means, what do you see? Foresee? How do you foresee the amount of uranium or the thorium or plutonium, which are output of that? But uranium, where we can run this our nuclear power plant, till when? I think somebody wants to know that they are not in limit, means infinite number. So how we can see that 200
Ah,
years, 500 years, or something like that? They want to know.
yes. We think numerically. We want a number tag for all our things. So we want to be quantitative. In fact, from the student community, this numerical felicity of expression is a very desirable property which I am finding. So as far as uranium is concerned, how much do we have? That's the question.
Yeah.
Now, uranium, we have known reserves pretty good. But we have uranium in untapped sources. It is not only our mines. We have uranium in seawater, 0.003 parts per million of seawater, an infinite, inexhaustible source of material from which we can extract uranium. We have rock phosphate, which contains uranium. And this uranium, when we use in the nuclear reactor, it is only the uranium has got two isotopes, uranium-238 and uranium-235. It is the 235 which undergoes fission, which gives you barium krypton, and so on. In fact, Director was mentioning about the separation of useful isotopes from the waste, converting waste into wealth. So we are getting from that because of the fission process taking place. So when we use that uranium-235, which is only 0.7%, 99.3% of uranium-238 is unused. That will absorb a neutron, will become uranium-239, beta decays and will become plutonium-239, which becomes the second generation fuel for our reactors. So you are using a larger, giving a large extension to it. But the most beautiful part of the untold story is what is known as breeding. Breed, and thou shalt flourish. What happens is, in the southern state of India, there is a monazite belt, almost 55 kilometer long, 5 kilometer wide, which contains probably next to Garapari, the largest reserves of thorium in the world, which is called the thorium, which is not a fissile material, but it's called a fertile material. But the fertility of thorium can be converted into fissionability by a nuclear process. Meshji. Transmission is affected. Hello.
I don't know. There will be, I think, the chart I have lost because I have to reconnect. Rajesh, if you have that old one, a couple of questions were there.
Yeah.
From, sir, there are some misconceptions. I think
Yes.
isn't asking the like these law means if you don't have the safety in a nuclear power plant, the accident may happen. So I think if you can share some information like how many accidents so far in nuclear industry as compared to the other industry, or what kind of safety measures are taken in nuclear power plant. I think that will be helpful for our audience to understand the safety level and these aspects of nuclear power plant. Please, sir.
Yeah. Yes. This is important we understand safety in its full form. Accidents happen because something that has been planned has gone bad. So absolute freedom from accident, that is impossible unless you build a huge infrastructure for that. But reasonable precautions are always taken. When a reactor is being designed, all that is known about the possible deviations or excursions are taken care of. And safety, not once, twice, thrice, triple redundancy is built into all the safety features. So every conceivable aspect has been taken care of, and over a period of time, a safety culture has been developed. In fact, the nuclear safety culture is the ultimate safety culture with respect to our industries. If you take a chemical safety, which will give you an idea, you have potassium cyanide, one of the most toxic substances you can think of. Take a small pinch and put it in your mouth, there you are gone, dead and gone in no time. That is the toxicity of a substance which we cannot do anything about it. So that is a fundamental, innate, basic, elementary property of a material to produce an injurious effect is called its toxicity. Potassium cyanide is classical example. The hazard, the probability that this will be used under the conditions and create an accident is called the hazard. The hazard can be controlled. For hazard control, we need engineering devices. You use a fume hood. You keep safety precautions that you are not accessible to that. Physical integrity. So radioactive materials and radiation sources are treated with the highest hazard evaluation possible. And there have been deviations from that, but there is a root cause analysis done for all these accidents. And we have very educative reports on what went wrong so that future doesn't take care of. To err is human. And to err is engineering also is possible. But not to err, safety engineering comes. Over a period of time, the finest of safety culture has been built and applied by nuclear safety engineering.
Yeah, in fact, in our gallery, we have shown in that nuclear power gallery, 7 layers of safety, which is normally applied when they are constructing a nuclear power plant. So they can learn from here how much safety precautions are taken so that because human life is very, very important. And in fact, in last lecture, Mr. Malhotra, he showed in one slide, I remember, if you find that nuclear death in any of the accident, hardly, I think there may be one or maybe none, if I remember it correctly. And there were only 3 major accidents which people normally remember, like Chernobyl, Green Valley, Fukushima. And only accidents means disaster, you can say, but there was no death reported from their effects. Yes, radiation effect, or that was because I think some of them they tried to conceal, you can say. For example, in Chernobyl, they said it came much later in the public domain, but then safety is much higher in that case. I think there is one word I came to know when we were implode and explode. So generally they are designed because double layer of that, so that if anything, even if it happens, it is imploded, means nothing will go out, everything will come low pressure, so everything will come inside even if something comes. Because normally hazards happen when they are exploding, is going into air, and in other places wind will carry them. Something like that we have mentioned. If I hope that is we have mentioned in the gallery, yes. And that people need to understand also. So it is much safer that way. Sir, now I think it's almost 1 hour and we are coming towards the end. In fact, I lost some of the chats. Some questions were there, but I hope I have covered those questions.
There was only one misapprehension was there, that this neutrino experiment will be harmful to the country. I found in the chat.
Okay, no, I could not, because when I lost the connection, I lost the chat also.
Our former president.
Yeah, you can take it up.
Dr. P Kalam has very clearly explained to all school students that the neutrino will do no harm to us. It is a fundamental understanding of the structure of matter, and India should be proud that such a high-profile experiment is conducted in our country. But it has been misrepresented, because fake news travels faster than faithful news. Its speed is lightning speed. With the velocity of light, it will travel. And wrong information, pseudo-facts, engineered facts, they travel faster. The neutrino will do us no harm. Let's be very clear about it.
In fact, they are continuously passing from here and there. So you need not to, but only thing is, they should not believe whatever is said. We must cross-check. What do you know, during in Corona period also.
People. Yes.
Yeah, I think if we remember that one of the scientists used the word, in fact, around that time only, infodemic. There's
Yeah,
a lot of
you-
information infodemic taking clue from that pandemic. So don't believe that is what the scientific tamper is. Even if say like Gautam Buddha said, even if I say something, until unless you are not sure about that, if you don't have the proof or if you don't have the literature sufficient proof, and you are not sure, you should not believe it that so easily. And that's what the perhaps scientific temper also says, that we can help a lot to the nation as well if we have that logical and scientific or rationality in our thinking. So coming, I think, towards the end of this, I will say, like Europe has declared it now, European Commission, that this is the green power. Many countries are going for it. India, in fact, in one of the book, I think it was by DAE chairman, Mr. Srinivasan, SR Srinivasan, if I'm not wrong. In a desk from a nuclear scientist table or desk, something like that. I was going through that. So there he mentioned that perhaps when he was DAE chairman, and after that he has put up that by 2020 or 2030 somewhere, we'll have almost 30% power through nuclear. But still we are far behind if you compare with that data or that prediction, I should say, with this current scenario in India, which is somewhere around maybe total generation around 5% or so. So what do you think, how means, what has made it so slow, you can say, or where we have missed that, because 30% as compared to the 5%, but there's a huge gap in that. And some of the advanced countries, because that is also being covered in news, when they, people who are going against that, they always quote those kind of things, that Germany is closing down, France is closing down, so they are going for other. So is there any reason specifically to the nuclear, or it is there are some other reasons because they have surplus power or they have less population, demand is less? So how do you think about that? So these two things here.
Well, if you look at current energy markets, you find a phase out by some countries, notably by Switzerland, Germany. They are trying to phase out because for political reasons, the Greenpeace, they want to appear green by being anti-nuclear. So that was but if you look at the nuclear economics projection by PricewaterhouseCoopers or Deloitte or any of these consulting groups, you will find that the money that has been pumped into the nuclear sector is inadequate to attain the targets we should have. Therefore, you will find, that is why I mentioned in the beginning, there is a nuclear renaissance. There will be increased investment. In fact, both PricewaterhouseCoopers and Deloitte are strongly advocating, although the capital intensity is high, operational cost is high, for safety and security and reliability and dependability of energy, the future energy mix of all the countries will have a strong nuclear component. But it needs political will, because political leadership is required. It's an investment where the state should take a lot of interest. We find increasing interest. China, India, Saudi Arabia, a number of countries have a new lease of life given to the nuclear power. So my contention is the economics makes it absolutely essential for us to go for nuclear. And we should have the right perspective from the governmental sector. If you would allow me to do a thought experiment for a moment, I would think if a person, an engineering leader like Dr. Anil Kakotkar, were the energy and power minister of this country, then the situation would have been very different. That foresight, that forecast, that engineering analysis, and that too energy engineering analysis, the quintessential existence required for us will have a new dimension if appropriate leadership is given to the energy sector.
I think that should be done, in fact, because that is the first exhibit in our gallery says with the civilization development and energy. So, and more energy is available, better will be the development and civilization development. So that is directly connected with that. Some of the advanced economies, they say why they are closing it down. It is just for some other reason, or
No, there are two reasons for that. One is business as usual mentality is happening. And two, they are still not aware of the consequences of closing this down. A total phase out of nuclear power, removing it from their energy economy, they still have not calculated. And Germany in particular is now ambivalent on this aspect.
But that is really a concern. On one side, we have sustainable development goal, and we are demanding for zero emission by 2070. And on the other side, we are trying to reduce or maybe going away from the powers which are as we have now after discussion also, and otherwise also say clean, green. With mitigating the effects of climate change, reducing better air quality, and less from more, I should say, means when it is land, whether it is land or a fuel. So far as fuel consumption is concerned, the small pellets or small fuel bundle can supply a lot of energy on that. I think there are some hands raised. If you allow maybe another 2-3 minutes, we can. Sahil Pol and Ayman Sheikh, I think they are very young children.
Yeah, very young.
They would
Bright
like to.
minds.
Yeah,
Yes.
Ayman Sheikh, you can ask question if you have related with this.
Hello again, sir. My doubt was who invented nuclear energy and why did he just name the nuclear energy? Was it any reason behind it?
I think who invented the nuclear energy? That's the question?
Yes.
Who invented the nuclear energy?
Oh, yes. The lady of fission first, who split the atom into two. You know her name?
I thought there was I just heard that it is a male scientist.
So the atom means uncuttable, unsplittable. But fission was discovered by a lady scientist. Then Enrico Fermi came and controlled the fission. We have the chain reaction. So we have a whole galaxy of atomic scientists who made the atom into the new format. Otherwise, atom means uncuttable, it remains there. We cut the atom, we split the atom, it went into the nucleus, brought out nuclear energy. And nuclear energy is so large, E is equal to mc squared. That is mass converted by the square of the velocity of light. That is the enormous dimension of nuclear power. This Meitner was the person who discovered fission, that the atom can be split.
Okay. So my doubt is like was there any intention of that Madame Curie that she just named it nuclear energy?
No, Madame Curie was working with the radioactivity. She used the radium for finding. She was working on radiochemical laboratories. She was understanding the atom, the radioactive atoms. Later, we tried to use the nuclear chain reaction. That is after Madame Curie.
Okay, sir. Thank you.
Yeah, much later means that E is equal to mc square means after that Einstein famous year 1905, yes. And later on the things were changed. In fact, I think there was one more that yeah. Any other questions we have from audience? I think Rajesh, because I lost in between. So if any question I have left,
I have been looking at it.
Okay. So I think it's already more than an hour. We have taken valuable time of yours, but I think it is worth, as you said in the beginning, social science responsibility. So I think it is again giving back to the society from a scientist who has spent 40 years in this field and communicating also, and still continuing his passion. And in fact, I should say I'm a fan of you, sir. I learned a lot, and you keep us also engaged sometime, giving us some assignment so that we take as a challenge and try to fulfill that so that we can connect more, creating scientific kits, you can say, or demonstration kits. So thank you very much, sir, I should say, and thank all our audience also. Some people have asked for the address of that DAE exhibition. It is in BRC campus. It is on VN Puru Marg, I think Mankurd area, nearest Harbor Line station is Mankurd. Those who are willing, it will be open till 7 p.m. today and also tomorrow. So 2 days were extended. But those who can, they should make it. You will learn a lot. Perhaps you can change your perception, not only perception, you can get some guidance or maybe a motivation or the spark so that you can become a nuclear scientist or a working person in that field, because BRC is a huge one. In fact, so far as concerns are concerned about radioactivity or nuclear power plant or radiations, let me tell you, I think there's a huge number of workforce, it is engaged with that. Some industries which are working indirectly or directly with them, they are creating employment to the tune of almost 2 lakh people that you will also find in the exhibition at some place. Yesterday I noted that. So if that would have been concerned, why people will be going there and working in that? Research reactors are there. In fact, yesterday I also learned that already research reactors are there. It is just nuclear power plant is just, you can say, one step ahead of nuclear reactor, because once you allow the heat to escape up to radioactivity, making isotopes and all that, and if you don't trap that heat, then nuclear power plant will not come into the picture. The moment you start using that heat, because you are using coal, you are using fossil fuels to generate that heat, to convert that water to the steam, and so that your turbine can run. And that's what perhaps is one step ahead. And credit to the Homi Baba sir, who was given that 3-stage nuclear program so that the least waste is generated. In fact, whatever is we are using, that is creating fuel for another one and that another one. So that's how the 3-stage program goes. So thank you very much, sir, and thank you all our audience. This will be keeping on YouTube also. Right now, I think it may be available on Facebook, but after having some editing and connecting both of them, because in between perhaps we lost, so there will be 2 films. We'll edit, join them, and put it together. Thank you very much, sir. It is always a pleasure to listen to you. And this time it was even more pleasure because I interacted live with you.
Thank you,
Thank you
Director Romeshji. It was a scintillating conversation and you made me refresh my memory at every question. I had to refresh my memory. Thank you very much for this charming scintillation, very scintillating conversation. Thank you.
Thank you, sir. Thank you very much.